Hey class, we're back again, and so we're working from chapter 8.4, and this is example 1, and we're going to look at reasoning about a scale factor and area. So here we have Jasmine making a kite from a 2 to 25 scale diagram. The area of the scale diagram is 20 centimeters squared. How much fabric will she need for her kite? So what we have to recognize first is that she's going off basically a scale diagram she's been giving. So when she builds the actual kite, it's going to be larger than the scale diagram. So we know we want a scale factor bigger than 1. So this ratio right here, or this rate, will give us our scale factor. So K, and if it's going to be an enlargement, it has to be bigger than 1. So it's going to be 25 over 2. Okay, so K is 25 over 2. Now, if you paid attention to the last video, what you'll recognize is this means there's going to be an enlargement of the area by a factor of 25 over 2 squared. And if we square these, 25 squared is 625. And 2 squared is 4. If you'd like a decimal representation, we can take our calculator and we can do 625 divided by 4, and that gives us 156.25. So this is the actual scale factor that the area is going to change by. So her new area, or I'm going to designate A new, would actually be the 20 centimeters squared, but we want to multiply that by a factor. Oh, sorry, I dropped a number there. It's 156.25. So 156.25. And so if we multiply those out, we get back 3,125. So 3,125 centimeters squared. One thing I would really advise to you is that you watch and don't just move the decimal place 2 places over and say that this is 31.25 meters squared. It's not quite that simple when you're dealing with square units. So either if the question doesn't specify, you can leave it as is, or you can come see me for some extra help and we can look at how you convert between 2 of those units. Okay, so that would be example 1, which is reasoning about scale factors and area. What I want to do now is I want to jump right into example 2 because that wasn't a very long video, and we're going to see if we can finish this unit off. So we have example 2, which is reasoning about a scale factor and the area to determine dimensions. So we've got Jim's laptop has a monitor with dimensions 9 inches by 12 inches. And you can see this is the actual measurements, or what we're assuming is the actual measurements of his laptop. The image on his laptop is projected onto the screen of a whiteboard. According to the documentation for the whiteboard, its screen area is 2,836.6875 inches squared. The image on the whiteboard is similar to the image on the laptop. It says determine the scale factor to used to project the images on the laptop to the whiteboard. So you'll notice here that this is given in inches, this unit's given in inches. So that's the first thing we had to make sure of. So what we're going to do is we're going to try and find out what actually would be the area of this. We're going to compare that area to the actual area of the screen given to determine the scale diagram. So if you think about it, we have area new. I'm going to try and set up an equation here. Area new is equal to 2836.6875, and that's inches squared. Now, the area old is given by, well, 9 inches times 12 inches. So if we calculate that out, we've got 9 times 10 would be 90. 2 more would be 18. So 18 and 90 gives us 108 inches squared. So you got to think, how did this area new come about? Well, the new area came about by multiplying by the scale factor squared. So if I set up an equation, 2836.6875 inches squared must have come about by taking my 108 inches squared and multiplying by whatever my scale factor was squared. So I'm trying to isolate K here. So my first move is going to be divide by 108. So I'm taking 2836.6875 and I'm going to divide that through by 108. So that's going to produce for me a value of 26.2656. I'm going to go to 4 decimal places for an intermediate step. And that's leaving me with K squared. So the next thing I'm going to do is I'm going to take the square root of both sides, and taking the square root of 26.2656 gives me back 5.125. Now, you're going to take the positive root here, because if you think about the scenario, it would give us back, it would return a negative area if we had negative dimensions if we use a scale factor of negative. So the negatives don't really make much sense contextually here for us. So we're going to take the positive or principal root for our scale factor, and this gives us our scale factor. If you wanted to round that up, you could do so, but I'm just going to leave all my decimals here. In part B, it says determine the dimensions of the whiteboard. Okay, so now that I know that this was my scale factor, I can simply look at the dimensions of my computer, and I can say, okay, well, what I'm going to call the height, I guess, mapping from this 9 inches, would come from taking the 9 inches and multiplying by my scale factor of 1.25. So if I do that, I've got 9 times 5.125, and that gives me back 46.125. So it's actually 46.125 inches is the measurement of the actual screen. So if we want to find the width of the actual screen, we would take our 12 inches, and we're going to multiply that by 5.125 as well. So taking 12 times 5.125, and that gives me back 61.5. So that ends up being 61.5 inches. And so those are the dimensions of my screen. So in a nutshell, the key ideas here is that if two 2D shapes are similar and their dimensions are related by a scale factor of k, then the relationship between the area of the similar shape and the area of the original shape can be expressed as the area of the similar 2D shape is equals k squared times the area of the original shape. So in short, area new is going to come from k squared times the area of the old. What you need to know is if the area of a 2D shape and the area of the original shape are known, then the scale factor of k can be determined using a formula k squared equals area of similar 2D shape over the area of the original shape. And if you look at the algebraic manipulation I did, it's the exact same as this formula. So that's it for chapter 8.4.